Okay, so you guys were supposed to calculate things. So tell me what you got. What was I crossed with J?
K.
K. What was J crossed with I? Negative K. That's weird, right? That's that not commutative thing. You guys see that? The cross product is a special kind of not commutative. It's exactly not commutative. Right? You guys see that?
Yeah.
A equals the negative of
Yeah, it's actually called anti-commutative, which is that when you switch the order, you get a minus sign. You guys cool with that?
What exactly is cross products?
Yeah, so we still don't have an understanding of what these are, but I think we can get there. Hang on a second. So I crossed with J was K, J crossed with I was minus K. What else did I ask you? What did you guys do?
K times J.
So you guys did K crossed with J, and you got
Negative I.
negative I. And if you did J crossed with K,
Let me guess.
should be getting positive I, which is, again, yeah, anti-commutative, right? And then, let's see, what else? There should have been some KI's. So there should have been K crossed with I and I crossed with K.
I can make an educated guess. The first one is J, and the next one is negative J, or vector J's.
So they're J's probably, right? And they're either minus or plus. You guys want a trick to figure it out? So this is a nice thing. Do you guys remember the right-hand rule about drawing our axes using the right-hand rule? So let me check here. So if I do I crossed with J,
And J.
that would be this way,
So it
right?
follows the right
So
hand
that
rule.
points at K. And if I did J crossed with I, that would be this way. It follows the right-hand rule. So you're sweeping your fingers through this vector, then that vector, and your thumb points in the direction of the output. You guys see that?
Yes.
So K crossed with I should be, so I'm putting my fingers through the Z-axis, then down to the
That'll
X,
be a positive.
and my thumb points
Towards J.
positive in Y. So I think that one's J.
And the next one's negative.
And then if I do X-axis to Z-axis, I point in the minus Y. So I get minus J out of this guy.
Okay.
You guys see that? What else is special about the cross product? So let me maybe write this down. So the geometry here, there are three things. There's the right-hand rule, right? Meaning you sweep your right hand from the first input to the second input, and then your thumb will point in the direction of this thing. There's the, what else is going on here? Yeah, you guys see that? With all of these, right? If I think about I and K, those make the XY plane, right?
Or perpendicular to the plane.
And then this is perpendicular to that. These guys, K and J, right? They make the YZ plane. And this is perpendicular to that. Just experimentally, right? I'm noticing that there's some kind of perpendicular. That's actually true. That's what the cross product does. So it takes two vectors and outputs a perpendicular vector, which explains why the zero vector one is broken.
Yep. Okay.
Right? The zero vector as an output for the cross product usually just means, yeah, dude, I couldn't deal with that. which happens anytime you have a zero vector in there, because it doesn't make a plane, right? So there's no unique perpendicular. Or when you have two vectors that are parallel. You guys see that? That's not going to give me an answer, right? It's like these guys. They don't make a plane, so there's not something that's uniquely perpendicular. It could be anything along this. You guys all see that? So that's going to give me a zero vector too, because there's not one answer. Okay, and then there's this other thing about the magnitude. So I need to actually be sure to write this down right. The magnitude of A crossed with B is the magnitude of A times the magnitude of B times the sine of the angle between them. Okay, and another thing you can think here is that this is the area of the parallelogram. So if you have a vector A and a vector B, this parallelogram here, the area of this guy is the magnitude of A crossed with B. Which makes that zero vector thing make more sense too.
Don't worry about the ambiguous case for sine,
For sine. What do you mean?
where it can be either an obtuse or an acute angle.
No, it won't matter.
Okay.
That'll give you the directionality, and that's taken care of by the right-hand rule. You guys all cool with that? So there are three things you need to know for the geometry of cross products. The right-hand rule, this perpendicularity thing, and this area of the parallelogram deal. Cool?
Okay.
Now, in no way have I shown you why this thing goes with the formula that I gave you to calculate, right? You guys all see that? So far as you know, those are two totally divorced concepts, which is, I'm sorry, the best you're going to get out of me today.
Okay.
Cool? So you'll have to trust me that those two concepts overlap, but they do. Cool, cool? Okay. Good. Should we use this for something? Quick? Okay. Let's learn a thing. We can use this for something. Okay. Well, an example. Crazy. So, use cross products to find a vector perpendicular to the plane containing 0, 0, 0, 1, 1, 2, and 3, 4, 5.
Those points are there.
Good question. Are those points or vectors? Yeah, in context, those are points.
But we can kind of apply vectors to.
But I can make them vectors quite easily, right?
Yep.
So it's a little bit important here that I made this plane go through the origin, right? Otherwise, I'll have to think a little bit harder, and I don't want to think very hard right now. So I have this point here, 0, 0, 0. Over here, I have another point that's 1, 1, 2. And up here, I have another point that's 3, 4, 5. Right? Please note this lacks perspective entirely. Cool? All right. So, what are two vectors that are in this plane? Don't think too hard.
1, 1, 2, 3, 4, 5.
Yeah, good. So this is a vector, right? 1, 1, 2 is in there. This is a vector, 3, 4, 5. That's also in there. That's cool with us? I want a vector that's perpendicular to this plane. So I should do a cross product, right? Anytime you think perpendicular, right? If you need to make a vector that's perpendicular, don't go anywhere else. Just get out the cross product, right? Just trot that sucker up and use it. So if I want to cross product these two vectors, which maybe I'll call, I don't know, u and v. So if you walk over here and do u crossed with v. Now, does it matter which order I do it in?
It decides whether it's, they're just going to be negative.
Good, yeah. Yes, it matters in the output, right? Like, it's going to make different output. But they're still perpendicular, so who cares? You guys all see that?
Just one's perpendicular going that way, the other's going perpendicular going that way.
Yeah, exactly. One of these is going to stick out of the board, and the other one's going to stick in. They're going to even be the same length, right?
Mm-hmm.
They're literally just going to have a minus sign. Fine, whatever. I'll deal with it. If you want one that points in a specific direction, you might want to think about this. It also pays to think about it just to know, like, if I do u crossed with v, I'm getting which one? Into or out of the board?
U cross with V into the board.
Yeah, I'm getting into the board. You should keep in mind that my picture might be really crappy.
Yeah.
Right? And I don't really know that those are the relative positions.
Wait, no, isn't it going out of it?
No, it's going into the board because I do u cross with
Yeah, I'm
v.
using my left hand, sorry. Kind of breaks.
Okay, so you calculate your cross product. You need I, J, K, and
We're doing U first.
yeah, I said I was going to do u first, so I'm doing 3, 4, 5, and
1, 1, 2.
1, 1, 2. Stuff times j minus stuff times, or sorry, stuff times I minus stuff times j plus stuff times k.
Your hand was like, no, it's not J.
And then,
8 minus 5.
good, 8 minus 5 and
6 minus
6 minus 5 and
3 minus 4.
3 minus 4.
We have gained
You guys all see this?
Yeah.
Does not have to take a ton of time. It would be super good if you were fast, but also accurate. I would rather have you accurate than fast.
So this is 3, -1.
So I
negative 1,
3
I
I
minus J minus K.
Oh.
minus j minus k, which as an honest vector is what?
3 minus 1 minus 1.
3, -1, -1.
I just skipped a step.
You guys all with that? Okay. What do I do now?
So you have the.
Yeah, freaking circle it and move on with your life.
So I'll give the vector a name so that we know it's a vector and not a point.
That's a fair point. I'm not going to.
Put it a vector omega.
But yeah, really you should probably label your answer something reasonable. So I'd label this like
V vector.
Steve.
Vector.
Okay.
Is there anything wrong with it?
Yeah, and you can certainly leave these in IJK form. Since we're doing math, I would prefer, I guess, if you use the standard vector notation, but I'm not going to count you off. What's up, Ryder?
Can we use the alligator brackets?
Yeah, if you want to use the right brackets, this marker's dead. But if you want to use the right brackets, that's fine. These guys.
Man brackets.
Most books use these for vectors. Your book uses the round ones. If you want to use these, I'm certainly not going to count you off for it. I will probably write these once in a while up here, and you'll have to like, hey dude, what does the pointy bracket mean? Cool.
That's almost only used in IJK so far. We haven't used the round bracket.
Yeah, they use IJKs in the beginning, and then once we get to actually doing more stuff, then they'll use the round brackets, and it is what it is. It took, the last time I taught this class, I shouted about this, and then like 4 days later, somebody was like, you know the book uses the round ones, right? It's like, no, they wouldn't be that stupid. No, they do. Other things? What's up?
So Merrill has a problem with this. I don't remember why. What is wrong with Greek vectors?
With what?
Greek vectors.
Oh, yeah, like
Oh,
the
yeah, because those are usually
vector of lambda.
Oh yeah, so lambda is a scalar, so
Oh, Greek
like it's
characters
just
are
a convention.
Oh, Greek
If you
letters.
want to make it a vector, you would just throw a hat on it. I would really rather if you just use the standard notation, which is like pick something in the U, V, W kind of range and put a vector hat on it. But that's just standard, it's not gospel. Does that kind of make sense?
Yeah.
I wanted
It's,
to,
yeah, Greek letters are scalars, and then
It's
the,
just convention.
You know, it's even weirder than that, because I would get annoyed with you if you wrote an X with a vector hat over it, because X is a single variable,
okay.
like it's a one-dimensional object in my head. But yeah, it's just a convention. If you draw a vector hat over it, fine. In fact, when I would get annoyed with you in here for it, but when we're doing linear algebra, I'll do it all the time. So it's
Yeah, that's what I was gonna say.
yeah, it's context driven and kind of weird.
real quick, everyone, we're doing the tutor.